Roisin McCarthy, and I'm the founder of Women in Data, and we are powering this session here today. You are in for a real treat. Green AI is the hottest topic this year at BDL, and it's with great pleasure we have a luminary of Women in Data, an unwavering partner as well in the organisation she works for. Please help me welcome to the stage Mulanga, Data Science and AI Manager for E.ON Next.
All right. Thank you. Oh, keep it. All right. Thank you very much. Like Roisin said, my name is Mulanga Makhubele, and I am a data science manager at E.ON Next. Can you all hear me? Fantastic. Thank you. And I am here to talk about green AI. Let's see if the slideshow works. Yes, it does. So I think all of us know that AI is exploding. Everywhere you go, everyone's asking, what's your AI strategy? What are we doing with AI? And businesses want it so much. So I saw this on my LinkedIn and I thought it was quite hilarious. And as a practitioner myself, working at E.ON Next, all I hear is, what are we doing with AI? We want it now. Can you give it to us? And outside of work, I'm also a parent. I have a 6-year-old. So I use AI and specifically ChatGPT to help me with my parenting. My latest use case for ChatGPT was, how do I get my 6-year-old to make her bed every morning without me having to ask her every day? And ChatGPT sent some suggestions. Here's some strategies that you can use. We had a back and forth. I sent some questions back, it answers, and eventually we got to a strategy. I'm happy to report that she's now making her bed most days, not every day. But the point is that interaction between me and ChatGPT was free. It took only an email for me to be able to enter into it. After the email, the back and forth, it's instant. So because of that, it's really easy for us to forget that there is a cost associated with doing that. The latest research from Sam Altman, who is the founder, the CEO of OpenAI, is that one AI query costs as much energy as a light bulb, switching on a light bulb for 10 seconds. Sounds really small, but from the interaction that I just mentioned, you and I know that I'm never just going to send one AI query to ChatGPT. I'm going to send a query, it's going to respond, we're going to have 5, 10 interactions, at least for just that one problem. So the AI issue is one of scale. Because I am doing it, and you're doing it, we're all doing it, you don't just end up with a light bulb being on for 10 seconds. It's actually more like billions of queries, trillions of tokens every single day. So to bring this to life in terms of how big the scale issue is, there is a mega data center that OpenAI is reportedly going to be building. That mega data center is supposed to be the size of Hyde Park. So can you imagine Hyde Park filled wall to wall with servers? That's the scale that we're talking about. And at that scale, there's energy that needs to be used to power those data centers. There's water that needs to be used to cool those data centers. And I have some numbers to bring to life the scale at which we've got. From a water perspective, you're looking at 40 to 50 Olympic pools to be able to cool that. As far as the power generation that will be required, the same amount that will be required to power cities like Bath or Oxford is what you're looking at. So it's a large-scale issue. And so if we are going to be building these products and using them, it's really important that we are conscious about how we're doing it. The good news, though, is that what we know about AI is that it has the potential to become the most powerful tool to help us solve climate change. We know that. It's already optimizing wind farms. It's predicting energy demand. It's accelerating breakthroughs in clean tech. But the fork in the road is more around how are we actually going to build this? There's old infrastructure that was used to build AI, that uses energy, that uses water. And there's an opportunity for us to think about these things differently and be more green, more energy conscious in how we think about building them. And that's the fork in the road for us. Do we accelerate the problem by building AI using old tech? Or do we reimagine the solution and look at greener ways of trying to build this? The good news is that the big tech companies like Microsoft and Azure are already thinking that way, and they are considering greener ways of building this technology. And we at E.ON Next are doing the same thing. We are keeping the lights on, that's what we do, but we want to do it using clean energy. We are powering the intelligence revolution, but we're doing it again with clean energy. And I am here to give you some tips and tricks in terms of how you can go ahead and do the same. Because the future of AI, it won't just be decided by CEOs or the people that are in parliament. It will be decided by practitioners and the day-to-day decisions that we choose to make. So I'm gonna give you some tips and tricks depending on what you do. I'll start with if you are a data scientist and you are in the audience. Model choice is a big deal. So bigger isn't always better. You want to use smaller, fine-tuned models. So I think if you are a data scientist, you've heard of BERT. There are smaller versions of BERT, like Hugging Face Distilled BERT. That's supposed to be 40% smaller than BERT, but it's actually 60% faster because it's a compressed version. And if you want to use that customer-facing in an interface, the inference speed of Distilled BERT is much, much faster than BERT. So not only is it a green choice to use Distilled BERT, but it will also delight your customers because we know that customers want quick and instant responses. There's another even smaller version of Hugging Face Distilled BERT called Tiny BERT. That's it's 2 to 9 times smaller, but it's also faster because it's even more compressed. Both of these were tested using NLP benchmarks, and you do lose 2 to 3% of accuracy compared to the original BERT. But if you think about it in terms of it's a greener choice, and of course it's compressed, which means it's faster and more efficient, then it feels like for specific use cases, maybe not in healthcare, where accuracy can be looked at differently, then that's a no-brainer as a choice. The second thing is that you want to track your carbon cost alongside accuracy. If you are a data scientist, you know that we obsess over loss functions and F1 scores. And what I'm here to charge you with, why not add an energy evaluation as part of the things that you will be obsessing with? There are some Python packages. CodeCarbon.io is a Python package. That Python package actually helps you track your energy consumption, the energy consumption of your code base, and the CO2 emission of your code base. So you can actually use that and add that onto your code stack to be able to measure how much CO2 is your code emitting. There's MLCO2, which is specifically for data scientists. It does the same thing, track the CO2 emission, but it's specifically for machine learning models, machine learning training and code execution. The third thing is that you want to experiment smartly. So hyperparameter tuning is a thing that we know that we need to do. There are traditional brute force ways of doing that, like grid search or random search, but I would like to propose that you might want to use more efficient ways of doing that. So RayTune is one, Optuna is one. These are actually, they are greener ways of doing hyperparameter search because they look at waste, they remove the waste from the process of hyperparameter search. And so those are options that you can take with you. And finally, you want to reuse and fine-tune. You want to train once and use often. Fine-tune instead of building from scratch. Hugging Face Optimum is it's a Hugging Face extension that you can use to optimize your code. It will do the quantization, it will do the pruning, make your code more efficient so that your code doesn't use as much energy as it would have otherwise. So that's a great tool. So that's for the data scientists and the ML engineers. Next, I'll be talking to the data engineers. If you are an engineer, it's all about location, location, location. So where you run your workloads matters. You want to push your workloads to data centers that are powered by renewable grids. There is a website called cloudcarbonfootprint.org. It will help you, if you're using AWS or Google Cloud or any of these cloud providers, if you go there, it will help you understand where it is that you can run your workloads. It helps you optimize for when renewable energy is peaking, like when the wind is blowing, when the sun is shining. That can help you in terms of where to put your heavy workloads. And then when you run also matters. So heavy training jobs, where you want those to happen when times when green energy is abundant. Some more tools that can help you with that. There's Carbon Aware SDK. So Carbon Aware SDK is a software development kit that you can add onto your stack. It helps your code become carbon aware, which means that it can help you automate running jobs when renewable energy is abundant, so that you are making greener choices. Carbon Intensity API is another one. It's less automated than Carbon Aware SDK, but again, it helps you understand when green energy is abundant and where you might want to choose to run your code there. And finally, from a water perspective, how you cool matters. Providers with water efficient or waterless cooling is what you want to use. So there's something called a water usage effectiveness. A lot of the big providers actually publish those. So you can go out and look for them and find out which ones are actually using water efficiently and how are they cooling their data centers to be able to run this. And then the last group I'll address is the business leaders. You want to start asking different questions. The question of what's our accuracy and is this model actually fulfilling the business problem is a good question, but that's not all you want to ask. You also want to ask, how energy efficient is this model? You want to ask, what is the carbon cost of this model? And you want to use your procurement power if you are a business leader. If you are deciding not to build models in-house and instead source other providers, other vendors to come and build them, you should use your procurement power to find out if these providers understand the energy mix. And if they don't understand it, then it should probably tell you all you need to know about how they're thinking about sustainability. So the World Economic Forum and the European Union Commission, they publish frameworks, and you can go there if you're a business leader to try and understand what are the right questions, what are the types of questions you should be asking your vendors so that you can make more sustainable choices. And then finally, you want to redefine your success. Our KPIs are the things that we track most closely, that we care about. And if sustainability in the AI world is something that you care about, you want to add a KPI that is tracking that, something that we can work on, something we can improve. And so energy per model is a KPI that you might want to add on as well. I suppose to round off my talk, the future of green AI isn't going to be written by algorithms. It's going to be written by us as practitioners. It's going to be written by every small decision that we are going to make. So as a data scientist, I know that when I build a model, there is energy that is used, and these things have a cost. And as a parent, I know that the decisions that we're going to make about efficiency, the decisions that we're going to make are going to affect the future of our children. And so we want to make the right decisions to be able to help our planet. So the question isn't necessarily just how powerful AI can become, but it's also how sustainable we can make it. And all of that is in the hands of everyone that's in this room. So I hope I have convinced you that when you go back, you start thinking more about, instead of doing things in the way we've always done them, what is a consideration that I can add? What is the consideration that I can make that can make the decisions that we're making create a better world for us and our children? Thank you.